This example introduces the transmission network model and associated graphics, and demonstrates the use of the AC load flow. With the project activated, you will see the project overview on the left-hand side. Study case 01 load flow should be activated, together with scenario-based scenario. The study case time is set at 5 p.m. on the 11th of January. This model contains profiled demand, and this time represents a peak winter demand. The project includes two single-line diagrams. The overview graphic has simple representations of the substations and sites and the connecting lines. The network consists of 4 grids and has been colored according to grid. The grid graphic has more detail, showing the individual busbars, generators and loads. There is also a geographic map of this hypothetical network, and a separate diagram for each grid. The load flow can be run using this button on the main toolbar. Look first at the basic options. An AC load flow will be run, with automatic adjustment of taps for phase shifters, transformers and shunts, and the reactive power limits of generators and SVSs will be observed. On the active power control page, the active power control is as dispatched, with any mismatch between generation and demand being taken up by the reference machine. Press execute to run the load flow. To see where the reference machine is, open a Network Model Manager and look at the synchronous machines. On the Load Flow tab, it can be seen that the reference machine is SWG8. Mark this in graphic and you can see that the active power from this machine is currently about 538 megawatts. To demonstrate its balancing role, let us switch generator SWG1 out of service. The load flow is then rerun. Now we can see that the mismatch is balanced by additional generation on SWG8. Generator SWG1 is made available again and the load flow run once more. We could alternatively use F10 as a hotkey for these repeated load flows, as we do not need to change any settings. Notice that different graphic coloring options have been selected for when a load flow has been run, to show the voltages of busbars relative to nominal, and the loading of lines relative to their thermal ratings. You can see how the lines connecting the northwest grid to the southwest grid are colored orange. They are heavily loaded at over 91% of their rating. Look at the overview diagram. Most substations are close to nominal voltage. To see voltages in detail, we can use a filter of busbars, like this. Here the flexible data page has been configured to show voltages when a load flow is run. We can further filter if, for example, we are just interested in the northeast. Let us see what effect it would have to split the substation in E03. Currently its two busbars are at the same voltage. We can split the substation from the substation or grid graphic by double-clicking on the bus coupler to open it. Rerun the load flow and we can see how the voltages are quite different on the two sides of the split. The breaker is closed again. Returning to the load flow settings, you can see that there is another active power control mode called according to secondary control. In this mode, the generation dispatch is managed by power frequency controllers. In this model there are two controllers, which can be found in a Network Model Manager. One controls the 4 generators in the southeast, to maintain the flow across the northeast-southeast interconnector boundary to a specified value. Here the value is set to -200 megawatts. The other controller controls the remaining generators so as to balance the network, in this case dispatching them according to their nominal output. To see this, first run a load flow with the active power control set to as dispatched. We can see that about 158 megawatts is being exported from the southeast. Now change the settings to be according to secondary control and run the load flow again. The generation has been adjusted to ensure a 200 megawatts transfer across the boundary.